Hello and welcome to Additive Insight, the original additive manufacturing podcast and your source for news, interviews and comments on the latest 3D printing and AM intelligence, brought to you by TCT Magazine. I'm your host, Sam Davies, and today I'm joined by Additive Assurance Chief Commercial Officer, David Menzies. Additive Assurance is a provider of in-situ monitoring and quality assurance technology for metal additive manufacturing and recently partnered with Nikon SLM Solutions. In recent years, the company has commercialised its AMiRIS product, with its technology being adopted in such industries as aerospace, defence, energy and healthcare. Throughout our discussion, Menzies details the core capabilities of AMiRIS, the motivation behind its partnership with Nikon SLM Solutions, and how the company hopes to keep pace with metal AM hardware providers as they scale their technologies. If you like what you hear, don't forget to subscribe wherever you get your podcasts. You can also head over to tctmagazine.com to subscribe to the TCT membership platform and receive more additive insights for our print and digital offerings. David, welcome to the Additive Insight podcast. You joined Additive Assurance in 2024. So tell us a little bit about your background prior to that, and also tell us what attracted you to this opportunity.
Yeah, thanks for the question, Sam. So I guess as the opportunity presented itself to me, I looked at it, I thought, well, what boxes does this tick? Is it an exciting technology category? Is it addressing an industry and a market that can it both interests me and inspire change, and being in advanced manufacturing and even better additive manufacturing, I looked at that. Okay, I thought, all right, that ticks that box. That's one of the primary motivations of being interested in a business. Next step, I looked at, well, at that stage it was a product that was developed, not necessarily a business that was formed at that stage. It was obviously a company. It was technically formed legally, but moving from a product to a business is really where you're standing on your own 2 feet, earning your keep, and it wasn't quite at that stage. So I had to look at it from the angle of the innovation process that they went through to get to the point of having a product developed. And the way I saw it, it was a customer-centric innovation process that had been done prior to that. And looking at that, I thought, okay, well, if the customer's in the middle and the customer's been listened to in the process, then something good is going to come out of this. It might need a little bit of tweaking, but 90% of the product's going to be pretty much right as long as there was enough listening and addressing any needs that came out in that process. Next part was looking at the people in the team. So I'd known Martin, one of the co-founders, for a couple of years, one or two of the directors in the business, and I looked at it, I thought, okay, well, tick, everyone seems to be nice and workable. There's clearly going to be a business case on paper at that stage if the right investors are sitting behind it. Was it still is a venture capital based business. And it's in an interesting market. So it was really a challenge on me, being someone who was coming in a commercial role, to look and address product market fit and make the product work and make it work as well as it can. So segue to my background. I'm a materials engineer by training, but I've spent most of my life in commercialization and product development of largely hardware-based technologies for various sectors, but really making sure that products are developed right and that customers are listened to in the process so that you can find that early market is something that I've spent most of my career on.
And how would you describe the challenges that Additive Assurance is trying to solve?
Yeah, so I'd probably look at that in 2 frameworks. One would be the industry level, and then the next one would be the implementation level. So at really the customer interface. So at the industry level, metal additive manufacturing is still something that is developing. It's not something that's been around for 200 years. It is still growing, which is great. So it's still at that exciting stage as an industry in its growth stage. It is hitting that maturity curve. So it's gone from that prototype, can you do something with this new cool thing, to how well can I make it now? So it's really gone through that big maturation early cycle as an industry. And the bit that we're trying to solve there as our business, the real challenge there is, can I trust it? How can I trust it faster? So what we're really about is in situ monitoring. That's looking at stuff real time to see if there's any problems that are occurring in the production process, and then translating that to a quality outcome. So really providing the right information from that data to make it easy for quality departments to sign off on. So that's the bit that we're doing. But I guess if you look at the other industry-wide challenge, there's not only the can I trust what I'm doing, there's also the overall economics in the situation. Can I get my production down to a certain cost level to justify changing from production system 1 to production system 2, being metal additive manufacturing? So the bits that we're contributing to that is really around, obviously, after building that trust, seeing if there's a way with the customer, with the industry, with standards bodies, to take that information and see if there's a way of reducing some of the reliance on the time and cost of post-process inspection. So that's kind of where we sit in the overall value chain. The other side being the company level, the challenges we have there, they're really cultural based ones, based on the company culture. So there's all the elements around new product acceptance and change management. And obviously beyond that, the inertia that businesses are set into to really help address that and see if there's ways that we can make it easy for product acceptance and approvals within.
So in terms of the product that you guys have developed, AMiRIS, can you explain what the kind of key capabilities of that product are?
So the AMiRIS is at its heart a quality device to help augment metal additive manufacturing. So what we offer is something that has real-time reporting, real-time anomaly detection, and a way for users to interrogate data in a way that they can't do with traditional post-process inspection, in order to make changes on the fly, should they be allowed to within their certification boundaries, and also for product development, process parameter development, and the likes, to be able to do things a lot faster. So that's, I guess, the outcome base. In terms of the product itself, it's something where we tend to split it up into 3 elements of discussion. One is the software. So it is something that is accessible with software. That is how the user gets the information from the data. Behind that, we've got analytics. So our entire product is driven by machine learning algorithms, which allow for the computation and processing of that data to happen extremely fast. It is something that happens within, say, 5 to 7 seconds at the end of each layer. The layer is completed, and all of the analytics is completed on that to then provide any quality information back to that user at that point in time. And then the last element is the hardware. So that there's, I guess, a couple of elements to that. One is, I guess, the sensor type that we're talking about here. So what we use is near infrared sensing, and what we've done is we've effectively designed a product to have accuracy and reliability of anomaly detection to below 100 microns. So that's 1/10 of a millimeter. And the most important thing is the accuracy and reliability. We can detect things down a lot smaller, but the smaller you go, the less confidence you have in that being an actual defect. So we've done quite a lot of work on probability of detection. We're doing some of that work in collaboration with route to market partners and end users as well, to replicate that in their environments so that they can gain the additional confidence for their implementation and rollout processes internally. So that's I guess, the way we tend to break down our product. But at the core of all of that is ease of use. So we want to make sure that whoever's accessing it for whatever reason they need to, it's easy for them to do it. Whether it's a maintenance person, whether it's production staff, whether it's a quality manager, whether it's a continuous improvement person, R&D manager and the likes, there's different ways that they need to interact with the product, and we've considered all of their workflows in how we've designed this product.
There are a lot of different in-situ monitoring products emerging in the additive manufacturing space. So how do you and the rest of the team kind of present this product? What makes it different to some of the other things that are on the market?
Yeah, I guess the first thing I always say when that's set as a scene is it's a good time to be alive. It means that we're doing a good thing. We're part of a pack that is trying to help drive change within that sector of an industry or that process within our industry. The way we tend to look at ourselves is really through that lens of the end user. I don't want to dwell over whether we have a visible camera or a near infrared camera or this type of sensor or that type of sensor. That's kind of a means to an end. The most important thing is the customer or the user understands what they've got in front of them, and they can make informed decisions on the basis of the information that's presented to them. To be able to do that, they need to have confidence in the data. So we spend a lot of time with customers to make sure that confidence is getting built into their quality decisions when they're going through a trial or a deployment. But I guess what we've got is that near infrared based implementation, and the way we look at that is that it probably provides the most broadest amount of rich data that can help a user understand quality as it's occurring within the laser powder bed fusion process, whether it's looking for pores, whether it's looking for spatter, something distorting, whether there's issues in the powder bed or the recoater. All of these things can be resolved in the part using that technique. So the reason why we developed a product based on that was because effectively it catches most of the quality issues as they're occurring, which is what we need to do to provide that confidence.
Obviously, AMiRIS, the kind of flagship product, predates you joining the company, but I think since you've joined, two other products have been released. One is AMiRIS LF, and the other is AMiRIS Inside. So I was wondering whether you could just quickly explain what those products do and how they complement the AMiRIS platform.
So they are extensions on the core product. So the core product was designed for what we now refer to as the smaller format platforms in laser powder bed fusion. That's your 200 to 300 millimeter build plate machines, your workhorse of the industry traditionally. So your EOS M290, your SLM 280, your 3D Systems DMP 320s, your Trump TruePrint. There's a whole raft of machines that fit in within that category. So the AMiRIS was designed to work as a external retrofit solution, going onto the viewing window and observing the process within there. AMiRIS LF does the same thing. It is a external retrofit going onto the front window, but it's doing it in the larger format platforms. So that's really to address the 450 to 600 millimeter platforms. So your Additive Industries metal fabs, your EOS M400s and the likes, that they fit into that category, which obviously have increased in popularity and use over the last 5 years, which is the reason for us extending our product to cover that as a category, especially if we as a business are trying to address production environment, which is what our product's been designed for. The smaller format machines, albeit ones that are still in production environment, may be less likely to be the decision made for someone building a new production environment, because they may get better economies out of a larger format machine. So we have to be able to address both. They're addressed the same way. All we do is increase the specification of the sensors that we have to be able to resolve that larger build plate. The analytics and the software are the same. So if you've got a Renishaw 400 and an EOS M400, you can use the same, not the same equipment, but you can use the same equipment architecture across both and be able to compare that data. AMiRIS Insight's a little bit different. So that's really the first implementation of that being with Nikon SLM Solutions for the NXG is where we're looking at doing mechanical integration with the machine OEM themselves. And that's really to address the integration of the hardware itself to make sure that's more secure and protected within the machine itself.
You mentioned the phrase production environment, and so if we look at the hardware in the metal AM space, that has been the kind of driver for all of those OEMs, is to make their machinery robust enough and performant enough to drop into those production environments. So I wanted to kind of ask the question of you, how has Additive Assurance ensured that its product is suitable for those kind of production environments?
Yeah, well, I guess the first thing you always do when you want to see if you're suitable for something is ask the question. So we've spoken to many different users across the globe in our target industries, and we can talk about target industries later. But we've spoken to them and asked them, what do they need? You know, what is it you're after here? And then obviously we've put our own lens on that, on that information, and come up with effectively a couple of core things that are central to our product. So that is ease of use, and I've spoken about that before, and I'll continue to do that because you have to have a product that's easy to use for someone to want to use it. You need to have something where there's outputs simple enough for someone, ideally with a lower level of qualification than a PhD or a master's degree, to be able to sign off on it and understand the information. I think an important thing for us to be able to scale this industry and to have a broader application of the technology is to be able to have a workforce that has a more of a vocational training pathway as opposed to an advanced degree training to be able to operate these machines. And we need to have rich data sets that sit in behind this for the acceptance within a customer environment, within that production environment, that there is enough reliability and accuracy. So you have to do a lot of proof points. So being able to represent data in many different ways, being able to show that you have that in a repeatable format, being able to have ways of looking at data in a navigable way to assist with whatever strange processes people have. One production environment to another, their quality management systems, sure, they're all ISO 9001 plus involved in there, but they've gone about it in a different way that meets their needs. So we need to make sure that we've effectively set up a flexible architecture where people can do what they want in a way that it has the flexibility to be able to shift with their requirements. So I guess the challenge in the production environment is, unless it's a new manufacturing site that's being built for a new application, you're already having to fit within an existing quality management system. And that is the big challenge. That's where the change management is. That's where the communication is. That's where all that soft work needs to be done within an organization to make sure that a great trial or a great implementation on a first machine or two or five is something that becomes a standardized process within the organization.
You touched on the target industries there, so let's get into that. What would you consider to be the target industries for Additive Assurance? Where are you seeing the technology being adopted the most?
Yeah, so I mean, no products for everyone. We see our product being really useful and in demand for critical industries where there are regulatory hurdles and requirements above the standard. So the industries that I call out there are aerospace, space, defence, medical, and energy, and they all have similar underlying requirements, but there's a couple of nuances within there. So some of the similarity in some of those is, I guess, the aerospace, space, and defence guys. They've been some of the early adopters of the very large format machines, being the NXGs, the EOS M400s, and the likes. And if there's something bigger, they'll probably get that one as well, because they can make a bigger end product from it. There's obviously going to be a limitation as to how big do you go, because it depends on what they're doing as a end user in their production system. But these larger machines are amazing. I mean, there's so much powder that goes into them, big parts that come out. Anyone who's into manufacturing just loves looking at them and seeing what you can do with it. The challenge is, however, your parts you're doing now on those large machines are ones you just can't inspect traditionally anymore. You're completely reliant on your coupons that you're printing next to it, which is indirect. It really creates a bit more of a drive within the user, their quality manager, their production staff. They really want to see how they can get the confidence and trust in every print in a way that they can do more expansion. And that's where I see the drivers with those customers. Obviously, they've got regulatory bodies they're going through. They've got certifications. They got everything, right? There's a whole bunch of things they're thinking about, but if you boil it all down, they've gone for large format machines, which means every low quality production event that occurs on that machine will have a much higher cost than doing it on a much smaller format machine, and they want to absolutely minimize that number down to zero. So if they can do that with a little bit of extra data during the process in a way that they can have confidence in it, they're going to do that. And they're the ones driving a lot of the change and desire for products within this sector. The other two, not so much using the very large format machines, but medical and energy. They've obviously got their own quality and confidence things they are trying to overcome to be the best business they can be, to offer the best product they can. And that is probably a little bit more of market forces and a bit of a regulatory certification side of it as well. But it's slightly different drivers, but really the same crowds that have an interest in situ monitoring. And it all comes down to having confidence at the earliest stage in the production cycle.
I appreciate those industries that you're working in are maybe not always the most forthcoming in terms of how they're using the technology, and they don't always like to talk about that. But I wanted to kind of ask from your side, how would you assess the impact that Additive Assurance has been able to have on some of those customers in some of those industries?
Yeah, no, it's interesting. So I think we're still at the early stage of adoption for in situ monitoring, to be fair. So what we're probably not seeing any industry-wide impact. What we are seeing is smaller ripples of impact within early adopter companies. And that's where they're having those light bulb moments that they've gone headlong, that they've put our equipment or one of our competitors' products into their production system, and they've looked at it. They've said, you know what, this does X for me, and it's given them that light bulb within their organisation, which is a lot different to you or I talking about it to them at a trade show and convincing someone that it's a great idea. Maybe it's a bit more of a research curiosity, but it's really those light bulb moments that are occurring within the industry sector at the moment that is giving people that drive to go, okay, well, we've got one. Let's see what standardization can look like for us. And that's kind of where we're up to as an industry. There's a few of those early adopters out there across mainly the critical sectors that I outlined earlier. And they are the ones that are going to reap the rewards early because they've gone through the learning curve and they've understood the benefits, the limitations, the implementation methods and that they're going to see those economic outcomes obviously a lot earlier than those that haven't. I always take my hats off to someone who's an early adopter. They're pioneers. They're amazing people, and they should be celebrated.
One thing I wanted to touch on today was the partnership with Nikon SLM Solutions that was announced maybe November last year, I think it was. I kind of wanted to ask you a couple of questions on that. So what do you think was kind of their driver for partnering with Additive Assurance and adopting AMiRIS, and what kind of what do you think this partnership can mean for the the certification of serial AM in demanding environments like we just talked about?
That was a very loaded question that I hope I can answer sequentially there. The partnership with Nikon SLM is amazing. I can't stress anymore how much it has provided additional confidence to the customer base. This is a relationship that was born again out of a customer-centric process. Common customers of Nikon SLM and Additive Assurance telling Nikon, being a bigger company, they can tell us all they like. You need to integrate with the product. Okay, we'd love to. That'd be lovely.
Yeah.
But those common customers of ours, talking to the machine OEM and saying, "Hey, we're doing this. It's great. You need to do it in your machine," is what really provided the starting point for that collaboration with Nikon SLM. Obviously, they go through very rigorous processes when they're working out who to partner with, what technologies they need to implement in their products. So we went through all of those common test cycles, as you'd expect with a company of the size of Nikon SLM. And at the end of that, they came out and said, "Look, we'll select your product. It needs to fit with the NXG platform," and that's what was announced last year. So it's been a very exciting journey for both teams, really, to see how we can get that mechanical integration to work, to get the most out of the combined experience out of both teams. 1 + 1 doesn't always have to equal 2. Sometimes you can get a bit of synergy and get something more for the customer in the process. That's what I'm always trying to look for here. So the customer starts the process. The customer's not kicked out of the process in that. The important thing is they are spoken to and part of the journey. So we have kept some of those key common customers informed in the process. They have come in and lobbed in the odd requirement or two. And it's a way of really gelling and keeping them involved, because at the end of the day, we're not innovating this for innovation's sake. Nikon SLM's not innovating this for innovation's sake. We're doing it for the customer. If we don't have the customer involved in that conversation, in that journey, we're probably going to make the wrong thing and they're not going to buy it. And it's not going to provide the outcome that everyone's after. The customer, Nikon, and us, we're all going to be disappointed and throw stones at each other. So if we don't keep them in and keep them engaged in the process, we're doing all of our partners a disservice. So for me, it's a customer-driven process. Nikon's made a decision based on not only what the customer said, but also what their internal requirements are. And then we've worked together to get to a great outcome point with the integration in NXG. Where that's at the moment is still in the verification and validation process. We are seeking to launch that shortly as a combined effort. And it is something we're very excited about. It is effectively our first announced partnership for the AMiRIS Inside product offering. Look, I couldn't speak more highly of the team at Nikon that we're working with. They're an amazing bunch of people, whether it's the legal team or the engineering team. They make it easy to work together, and they also have the same ethos that we do of keeping the customer in the middle, which is important.
I wanted to ask you about the kind of trends in metal AM, one of which is enlarging the build envelope, putting more lasers in there. Nikon SLM are one of those companies that are kind of pushing to increase the size of the machine. 12 lasers in there at the moment. Obviously, we touched on the AMiRIS LF product a little earlier, and I guess I wanted to ask you that as these hardware suppliers do that and they make the machines bigger, they throw more lasers in there. What challenges does that present for you, Additive Assurance, to kind of keep pace with that and make sure that your product can still do what it's intended to do at those larger scales?
Yeah, no, it's interesting, and it is the trend, right? You are seeing it at the moment. Obviously, there's two trends that you've seen in the broader industry context. One is let's get machines bigger to address bigger parts, which is great. At the same time, also address the economics. If you've got the right volume requirements with a large machine, you can make lots of parts, and therefore you can drive your economies of scale through that. And the other one is let's make machines a lot cheaper, which is the other way of addressing that same cost per part problem. But I guess with larger machines, you've got potentially larger problems. So what your need for information as early as possible becomes even more critical. So as these machines scale, the requirements on data and information become more ever present. They're not going to go away. Users of large machines have become accustomed to looking for more data, doing more testing, doing more to make sure that they're sitting within their right economic envelope. The real challenge there is scalability. If you're thinking about auxiliary or ancillary equipment that needs to fit within that new sort of larger core machine. So with I guess the way we've got our product architecture, we're agnostic to the number of lasers that are present in the system. So that doesn't really bother us whether they've got 12, 8, 4, 32. It's the same thing. Effectively, it's a brightness scale when you're looking at near infrared as an effect, and you can cover that with some filters effectively if things get too bright. That's the scalability question. Then you got size, right? So when you go to 600, if you then double that to 1.2 meters, you effectively need to scale your number of sensors to resolve everything to the appropriate level. And a lot of that comes into the design and innovation process. So the earlier decisions are made by the integrator, by that product integrator, the better, because it can make it easier for, I guess, sensing partners like us to make sure that we've got the right thing for that situation rather than shoehorning something in and hoping it works. So what we've ended up by doing with the NXG is obviously a pre-existing product, but luckily enough for us, there was enough space to fit in everything we needed to because the machine is so large. If that machine was half the size of that and we had to stick in all the things we have to do to be able to do what we need to do at the right quality level, then it could be a case of square peg, round hole. And that's the challenge you always get when you're coming in after 95 meters into a 100 meter race. You just have to fit, otherwise you don't fit. But that larger build volume obviously creates larger problems for the customer in the event of cost of poor quality. So the customers obviously got that in their focus set. The machine makers have got it in their focus set because it's a larger revenue per unit for them in terms of manufacturing. So every single person involved in that value chain has the same metrics that they are worried about. It is underlying all of that, it's confidence and quality that needs to win that game. The economics follows.
Finally, David, and thank you for your time today. with everything in mind, everything that we discussed today, what are you able to tell us about the future evolution of the product portfolio, and I guess the challenges that Additive Assurance is looking to address moving forward?
Yeah, look, there's no shortage of challenges, Samuel. So, what we are really wanting to do is to follow the journey that we've sort of laid out to date. So we started off with looking at the smaller machines, largely because they were for the R&D environment and more accessible, then shifting to the production, more production now, newer workhorse machines being yet those sort of medium to larger size formats, and then obviously the very large machines like the NXG. The whole transition from that external retrofit product that we came up with originally as a business, it's great. It's able to be adopted very quickly. You don't affect your machine warranty. It's got a lot of benefits. But at the end of the day, in a production environment, as opposed to a R&D environment, sometimes there are rules within that production system that don't allow for things to be placed on machines because they've already been certified. So in an environment like that, which is not all environments, only some are like that, we aren't able to step out of the research lab into the production environment, even if we have something that is agreed, certified, signed off at the board level, everything. So AMiRIS Inside is a big focus for us. The work we're doing with Nikon SLM is critical in that, and we're going to continue to do that. I guess from the other side of things, machine learning and software features are things we're always working on. So whether it's about I guess enhancing some of the accuracy, getting things another 10% better, we're always looking at ways of achieving that. But more importantly, we've got a lot of data there. We're analyzing for certain things. What other things can we find in that data? And then how can we provide that to a customer in a way that they value and understand and can do something with? Those are the things we're always spending our time with. Those are the things that are keeping us up at night. How can we do more to make the customer happier? And I guess at the end of the day, we are currently on the market with a single mode sensing. That's that near infrared band that we're looking at. We are looking at ways we can fuse that data with other sensing modes. And I think that is something that's probably an interesting element for a later discussion once that product's ready. But the thing with data fusion, you could stick two bits of data together every day of the week, right? Does it do anything? That's the main thing. So what we're doing is we're doing a lot of testing to seeing, can you get any more out of it? Where's the synergy? If all it does is present 1 + 1 = 2, no one values that. There is no value in it, and you shouldn't talk about it because it's not addressing a problem. It's not creating a solution. It's doing nothing the world needs. What we need to do is do something that addresses something that's unmet, that is creating a problem somewhere, or can help an unlock that can allow scaling of additive manufacturing. So that those are the things that we're really working on as a business, with the view to obviously make the world a better place, and additive manufacturing grow and continue to grow.